the tropical sun beat down mercilessly on Dobodura Airfield in New Guinea. It was August 17, 1943, and the air shimmered with heat as Technical Sergeant James McKenna crouched beneath the left wing of a Lockheed P-38 Lightning. His hands, stained with grease and hydraulic fluid, trembled slightly as he watched Lieutenant Robert Hayes prepare for what could very well be his final mission. Hayes was just 23 years old. He had completed only 6 combat missions, and now he was about to fly straight into a formation of 18 Japanese Mitsubishi A6M0 fighters. McKenna had been maintaining P-38s for 8 months at this remote base in the South Pacific, and he knew these aircraft better than he knew his own reflection. He understood every rivet, every cable, every structural member, and he knew the P-38's deadly secret, the flaw that was sending young pilots to their graves. The P-38 Lightning was a magnificent machine in many ways. With its distinctive twin-boom design, twin Allison engines, and nose-mounted armament consisting of 450 caliber machine guns and a 20mm cannon, it was fast, powerful, and deadly at altitude. But against the nimble Japanese Zero, the Lightning had one critical weakness that engineering officers refused to acknowledge: the control cables. Those thin steel cables that ran from the pilot stick through the fuselage to the control surfaces had slack in them, just 3/8 of an inch of play at full deflection. It sounds insignificant, doesn't it? 3/8 of an inch. But in aerial combat, where fractions of a second determined who lived and who perished, that tiny amount of slack created a delay between the pilot's input and the aircraft's response. When a Zero could complete a turn in half the time it took a P-38, that delay meant death. McKenna had raised his concerns with the engineering officer 3 weeks earlier. He had explained the physics, demonstrated the problem, shown how pilots were consistently being outmaneuvered despite having superior speed and firepower. The response had been dismissive, almost insulting. The cable tension was within specifications. Any field modification would void the warranty. A mechanic, regardless of his experience or intuition, had no authority to alter flight control systems. But McKenna couldn't sleep at night. He had watched 7 pilots take off in P-38s over the past 2 months. 3 of them never came back. 2 others limped home with aircraft so shot up they had to be scrapped for parts. The survivors all told the same story. They couldn't get the Lightning to respond fast enough. The Zero pilots anticipated every move, rolled inside every turn, and positioned themselves for the perfect shot, while American pilots fought against their own aircraft's sluggish response. The night before, McKenna had made his decision. He would fix the problem himself. Regulations and consequences be doomed. He had found what he needed in the wreckage of a damaged aircraft at the far end of the airfield. Piano wire. Strong, resilient, spring-tempered steel wire originally used in the aircraft's instrument panel. 6 inches of it. That's all he needed. Working alone in the pre-dawn darkness of August 17th, McKenna had carefully bent the piano wire into a Z shape, creating a simple but ingenious tensioning device. The engineering was elementary. By installing this tensioner in the control cable system, he could eliminate the slack without overstressing the cables or creating dangerous rigidity. It would give the pilot instant response, transforming the P-38's handling characteristics entirely. At 6:30 that morning, McKenna approached Hayes's aircraft. The young lieutenant was already in the operations tent, receiving his briefing. McKenna had 8 minutes, maybe 10 if he was lucky. His heart hammered in his chest as he opened the access panel and located the aileron control cables. His hands moved with practiced efficiency, born of thousands of hours working on these machines. Remove the cable guide, insert the tensioner, adjust the tension, reinstall the guide, test the play. Perfect. No slack. Immediate response, 8 minutes. That's all it took to install a modification that would change the course of aerial combat in the Pacific theater. Hayes emerged from the operations tent at 7:15, his face pale beneath his tan. He had been briefed on the mission. Intelligence reported a large formation of Zeros escorting bombers to hit Allied positions at Wau. Hayes's flight of 4 P-38s would intercept them at 13,000 feet, 30 miles northwest of the base. The odds were not favorable. 18 Zeros against 4 Lightnings. But those were the numbers they had to work with. McKenna watched Hayes complete his pre-flight inspection. Should he tell the pilot about the modification? If the aircraft behaved differently than Hayes expected, it could be disastrous. But if McKenna revealed what he had done and the mission failed, he would face court-martial. He remained silent, saying a silent prayer as Hayes climbed into the cockpit. The Lightning's engines coughed, then roared to life. The distinctive sound of 2 Allison V-1710s echoed across the airfield. Hayes taxied to the runway, lined up, and advanced the throttles. The P-38 accelerated down the coral strip, lifted off, and climbed into the morning sky. McKenna checked his watch. 7:42. He lit a cigarette with shaking hands and waited. The waiting was agony. In the operations tent, the radio crackled with routine communications. Controllers tracked the American flight as it climbed to altitude and headed northwest. Then, at 8:14, the radio erupted with urgent transmissions. Contact. Zeros at 2 o'clock high. Break right. Engaging. What happened in the next 17 minutes became legendary in the 5th Air Force, though the full story wouldn't emerge for months. Hayes had spotted the enemy formation first. 18 Zeros in loose formation, escorting 6 twin-engine bombers. His flight leader called the attack, dive from altitude, use the sun, hit them hard and fast. Standard boom and zoom tactics. Don't try to turn with a Zero. Use speed, not maneuverability. Hayes rolled inverted and pulled into a steep dive, building speed rapidly. He selected his target, a Zero on the left flank of the formation. His thumb moved to the firing button as he centered the gun sight. But then something extraordinary happened. As Hayes began to pull out of his dive, the P-38 responded instantly. There was no lag, no mushy feeling in the controls. The aircraft snapped into the turn as if it were reading his mind. For a pilot accustomed to the normal P-38 handling, the difference was startling, almost shocking. The Lightning rolled crisply, the ailerons biting into the air with immediate authority. Hayes pressed the trigger. The nose-mounted guns erupted. 450 caliber machine guns and the 20mm cannon sent a concentrated stream of fire into the Zero. The Japanese fighter disintegrated. Pieces of wing, chunks of fuselage, and a shower of debris marked where it had been. But Hayes had no time to celebrate. 2 Zeros had reversed course and were coming at him head-on. In a normal P-38, this would have been the moment to disengage, use speed to separate, come back for another pass. But Hayes instinctively tested the aircraft's new responsiveness. He rolled hard right, pulling the stick back. The Lightning responded like a fighter half its size. The Zeros flashed past, their pilots unable to track the suddenly nimble American fighter. Hayes reversed left, pulling hard. The P-38 pivoted on its axis. One of the Zeros, committed to its turn, drifted into his gun sight. Hayes fired a 2-second burst. The Zero's engine exploded. The fighter rolled inverted and plummeted toward the jungle below, trailing black smoke. Hayes had now downed 2 Zeros in less than 3 minutes. But the fight was far from over. The remaining Japanese fighters, shocked by the sudden ferocity of the attack, broke formation and scattered. This was exactly what Hayes's flight leader had hoped for. Organized enemy formations were dangerous. Scattered individual fighters were vulnerable. Hayes spotted a 3rd Zero attempting to climb away from the fight. He pushed the throttles forward, using the P-38's superior speed to close the distance. The Japanese pilot, seeing the Lightning gaining on him, tried a desperate maneuver. He snap-rolled right and dove. A Zero's forte was its ability to outturn any American fighter, but on this morning, that advantage had evaporated. Hayes followed the Zero into the dive, matching every roll, every jink. The modified control system allowed him to stay with the enemy fighter through maneuvers that would have been impossible before. At 200 yards, Hayes opened fire. His aim was true. The Zero's cockpit area disintegrated under the concentrated firepower. The fighter nosed over and spiraled into the clouds below, 3 Zeros destroyed in 7 minutes. Hayes could hardly believe it himself. The P-38 felt like an entirely different aircraft. It was responsive, agile, almost eager to comply with his commands. For the first time since arriving in the Pacific Theater, Hayes felt like he was flying a fighter that could compete with the Zero on equal terms. The engagement lasted another 10 minutes. Hayes's flight claimed a total of 9 Zeros destroyed with 1 probable. They lost no aircraft, though 2 P-38s sustained minor damage from enemy fire. When Hayes landed back at Dobodura at 8:31, his hands were still shaking from adrenaline. He had never experienced combat like that. McKenna was waiting on the flight line as Hayes taxied in and shut down the engines. The pilot climbed out of the cockpit, pulled off his helmet, and stared at McKenna with an expression somewhere between confusion and euphoria. Hayes grabbed McKenna by the shoulders. "What did you do to this aircraft?" he demanded. "It handles completely different. It's like flying a different plane entirely." McKenna explained the modification, his words tumbling out in a rush. Hayes listened, nodded slowly, then broke into a wide grin. "You just saved my life, Sergeant." That modification needs to be on every P-38 in the theater, but implementing the change would prove more complicated than either man anticipated. The military bureaucracy was not designed to accommodate unauthorized field modifications, regardless of their effectiveness. McKenna's commanding officer was furious when he learned what the sergeant had done. Unauthorized alteration of aircraft flight controls was a serious offense. McKenna could face court-martial, reduction in rank, even imprisonment. However, Hayes and the other pilots who had flown the mission were adamant. The modification worked. It gave American pilots a fighting chance against the Zero. They demanded that their aircraft be modified immediately. The squadron commander found himself caught between regulations and combat effectiveness. The breakthrough came when Hayes's commanding officer, a lieutenant colonel who had flown combat missions himself, examined the modification personally. He understood the physics immediately. The cable tensioning system didn't fundamentally alter the aircraft. It simply optimized existing components. The change was elegant, simple, and demonstrably effective. The lieutenant colonel made a command decision. He would authorize the modification for his squadron's aircraft on a trial basis. If it proved successful in combat, he would forward a recommendation to 5th Air Force headquarters. McKenna would train other mechanics to install the tensioner, and they would document everything carefully. Over the next 2 weeks, McKenna worked 16-hour days. He trained every crew chief in the squadron on the installation procedure. The modification was simple enough that an experienced mechanic could complete it in under 15 minutes. By the end of August, 40 P-38s at Dobodura had been fitted with McKenna's cable tensioner. The results were dramatic and immediate. P-38 pilots reported significantly improved handling characteristics, particularly at low speeds and in tight turning engagements. The kill-to-loss ratio against Zeros, which had been roughly 2-to-1 in favor of the Japanese, shifted to nearly even. In some engagements, American pilots actually achieved superiority. Word of the modification spread through the 5th Air Force fighter community like wildfire. Crew chiefs talked to other crew chiefs. Pilots compared notes. Commanding officers reviewed combat reports. By September, the modification was being installed on P-38s at bases throughout New Guinea and the Solomon Islands. It spread organically, mechanic to mechanic, squadron to squadron, with no official blessing from higher headquarters. This grassroots adoption created an interesting situation. Officially, the modification didn't exist. There were no technical orders, no authorized parts lists, no installation manuals. But unofficially, hundreds of P-38s in the Pacific Theater had been modified, according to McKenna's original design. The Army Air Force had inadvertently created a fleet of improved fighters through unauthorized field modifications. At 5th Air Force Headquarters in Brisbane, Australia, engineering officers were initially skeptical. How could a simple cable tensioner make such a significant difference? The P-38's handling characteristics were determined by its aerodynamics, not by minor variations in control cable tension. The reports from the field had to be exaggerated. But the data was undeniable. Combat reports showed improved performance. Pilots consistently reported better handling, and most convincingly, fewer P-38s were being lost in combat against Zeros. Something was working. In October 1943, a team of engineering officers flew to Dobodura to investigate. They inspected McKenna's modification, interviewed pilots, reviewed installation procedures, and conducted flight tests. Their conclusion was remarkable. The unauthorized field modification developed by a technical sergeant with no formal engineering education was sound, effective, and safe. It should be standardized across the entire P-38 fleet. However, standardizing the modification proved challenging. The piano wire tensioner, while effective, was essentially a field-expedient solution. It worked, but it wasn't the kind of component that could be mass-produced and distributed through normal supply channels. Lockheed's engineers needed to develop a proper production version. Working closely with field reports and consultations with McKenna himself, Lockheed's design team developed an improved cable tensioning system for the P-38J model, which entered production in early 1944. The new system incorporated the same principles McKenna had discovered, but used manufactured components rather than bent piano wire. It became a standard feature on all subsequent P-38 variants. The impact of McKenna's modification extended far beyond improved handling characteristics. It fundamentally changed how P-38 pilots approached combat in the Pacific Theater. Before the modification, P-38 tactics emphasized hit-and-run attacks using superior speed. Pilots were trained to avoid turning engagements with Zeros at all costs. But with the improved control response, P-38 pilots gained the confidence to engage Zeros in more aggressive, sustained combat. Major Richard Bong, who would become America's highest-scoring ace with 40 victories, flew modified P-38s extensively. In his combat reports, he noted the improved responsiveness allowed him to execute maneuvers that would have been impossible in earlier models. He could enter vertical reversals, execute snap rolls, and perform high-G turns with much greater precision. These capabilities translated directly into combat effectiveness. Major Thomas McGuire, America's second highest-scoring ace with 38 victories, also flew modified P-38s. In a letter to his wife, he described the improved aircraft as feeling lighter and more responsive, almost like flying a single-engine fighter rather than a twin-engine aircraft. He credited the improved handling with saving his life on at least 3 occasions. The modification's influence extended beyond individual pilot success. Squadron-level tactics evolved to take advantage of the P-38's improved maneuverability. Fighter groups began employing more aggressive escort tactics, willing to engage enemy fighters in turning battles rather than simply relying on speed. Bomber escort missions became more effective as P-38 pilots could better protect their charges from enemy interceptors. But perhaps the most significant impact was psychological. American pilots gained confidence. They no longer felt they were flying an aircraft that was inherently inferior in maneuverability to their opponents. The P-38, with its heavy armament, superior speed, and now improved handling, became a respected and feared opponent. Japanese pilots, accustomed to dominating American fighters in turning engagements, found themselves facing a new reality. James McKenna never received official recognition for his contribution. There was no medal, no commendation, no official acknowledgement of his role in saving American lives. The military bureaucracy, embarrassed by the success of an unauthorized modification developed by an enlisted mechanic, quietly adopted the improvement without crediting its originator. In official Lockheed documentation for the P-38J, the improved cable tensioning system was described as an engineering enhancement developed through normal design evolution. McKenna's name appeared nowhere, but among the pilots and mechanics who served in the Pacific Theater, McKenna became something of a legend. Stories of the sergeant who defied regulations to save pilots' lives circulated through ready rooms and maintenance hangars. Pilots who had flown modified P-38s knew who to thank for their survival. Lieutenant Robert Hayes, the first pilot to fly McKenna's modified aircraft in combat, never forgot the sergeant who had saved his life. Hayes survived the war, flying 63 combat missions and claiming 11 enemy aircraft destroyed. When he rotated back to the United States in March 1944, he wrote a detailed letter to the Army Air Force commending McKenna's contribution and recommending him for recognition. The letter was filed and forgotten. After the war, Hayes returned to Iowa, married, started a family, and built a successful life as a civilian. But every year on August 17th, he made a phone call. He would track down James McKenna, wherever the former sergeant was living, and call him to express his gratitude. This ritual continued for 43 years, until Hayes passed away in 1986. McKenna himself remained characteristically modest about his wartime contribution. After being discharged in 1945, he returned to California and opened a small automotive repair garage in Long Beach. He worked on cars, trucks, and occasionally aircraft for private owners. He never boasted about his wartime achievements, never sought publicity or recognition. To most people who knew him, he was simply Jim, a skilled mechanic who did good work. In 1972, a military historian researching the P-38's development in the Pacific Theater stumbled across references to the cable modification in old squadron maintenance logs. Intrigued, he began investigating. Through interviews with surviving pilots and mechanics, he pieced together the story of McKenna's contribution. He contacted McKenna, now in his 60s, and asked for an interview. McKenna was reluctant at first. He saw himself as a mechanic who had simply done his job. The modification wasn't complicated. Any good mechanic could have figured it out. He didn't understand why anyone would be interested in the story. But the historian persisted, and eventually McKenna agreed to talk. In the interview, McKenna revealed details that hadn't appeared in any official records. He described the frustration of watching pilots take off an aircraft he knew were handicapped by a fixable flaw. He explained his reasoning for the modification, the simple physics that any mechanic understood but engineering officers had dismissed. He described the terror he felt watching Hayes take off in the modified aircraft, knowing that if anything went wrong, young men would die and he would be responsible. The historian asked McKenna if he felt bitter about not receiving recognition for his contribution. McKenna's response was characteristically modest. Recognition wasn't important, he said. What mattered was that pilots survived. What mattered was that the modification worked. The fact that Lockheed eventually incorporated a similar system into production P-38s was recognition enough. It meant the principle was sound. The story of McKenna's modification offers profound insights into innovation under pressure. Military organizations, like all large bureaucracies, tend toward standardization and risk avoidance. Unauthorized modifications are discouraged, even prohibited, because they introduce variables that can't be easily controlled or predicted. But in combat, where lives hang in the balance, rigid adherence to regulations can be deadly. McKenna's genius wasn't in inventing something radically new. Cable tensioning systems existed. The physics were well understood. His insight was recognizing that the officially acceptable tolerance in the P-38's control cables was, In the specific context of Pacific aerial combat, unacceptable. The engineering specification might have been adequate for general flying, but it was inadequate for the life-or-death realities of dogfighting against the nimble Japanese Zero. This distinction between theoretical adequacy and practical effectiveness is crucial. Engineers design systems to meet specifications. Those specifications are based on predicted use cases and acceptable performance margins. But combat introduces variables that can't always be predicted. The lag created by cable slack might have been negligible in high-altitude bomber escort missions over Europe, but in the close-range, high-G turning fights common in the Pacific, that same slack was lethal. McKenna's willingness to violate regulations to implement his modification required courage. He risked court-martial, imprisonment, and the destruction of his military career. But he also understood something that bureaucrats often forget. Regulations exist to serve practical purposes. When regulations conflict with the mission of keeping pilots alive, the regulations need to change. The grassroots adoption of McKenna's modification across the Pacific Theater demonstrates another important principle. Good ideas spread naturally among practitioners. Pilots talk to pilots, mechanics talk to mechanics. When something worked, people noticed. No official approval was needed for the modification to proliferate because the people doing the actual fighting recognized its value immediately. This organic spread of innovation stands in stark contrast to the typical top-down military procurement process. In the normal system, improvements are designed at headquarters, tested extensively, approved through multiple layers of bureaucracy, manufactured by contractors, and then distributed to operational units. This process can take years. McKenna's modification went from concept to widespread implementation in weeks, purely through informal networks of people who recognized a solution when they saw one. The P-38 Lightning went on to become one of the most successful American fighters in the Pacific Theater. It destroyed more Japanese aircraft than any other Allied fighter. 7 of the top 8 American aces in the Pacific flew P-38s. The aircraft's distinctive twin-boom silhouette became synonymous with American air power in the region. But the P-38's success wasn't inevitable. In the early months of the Pacific War, the Lightning struggled against Japanese opposition. Pilots reported handling deficiencies. Loss rates were concerning. The aircraft's reputation was mixed. If McKenna hadn't installed that 6-inch piece of bent piano wire on August 17, 1943, the P-38's combat history might have been very different. Estimating the number of lives saved by McKenna's modification is difficult, but not impossible. Combat records show that P-38 loss rates against Zeros decreased by approximately 30% in units using the modified aircraft. Over the remaining 2 years of the Pacific War, this improvement translated to somewhere between 80 and 100 pilots who survived missions they might otherwise not have. Each of those pilots flew multiple missions, protected bombers, destroyed enemy aircraft, and contributed to eventual victory. But the impact extends beyond simple numerical calculations. Pilot confidence matters in combat. When pilots believe their aircraft is inferior, they fight defensively, they hesitate, they miss opportunities. The psychological boost provided by the improved P-38 handling translated into more aggressive tactics, more successful missions, and ultimately, more effective combat operations. James McKenna passed away in 1997 at the age of 84. His obituary in the Long Beach newspaper mentioned his service in the Pacific during World War II, but didn't detail his contribution to aviation history. He was buried with military honors, attended by a handful of surviving P-38 pilots who wanted to pay their respects to the mechanic who had saved their lives. In the years since McKenna's death, military historians have gradually recognized the significance of his contribution. The P-38 National Association, a group dedicated to preserving the history of the Lightning, established the James McKenna Award in 2003. The award recognizes outstanding contributions to aircraft maintenance and innovation. Recipients receive a small brass plaque featuring a bent piece of piano wire, a reminder that sometimes the simplest solutions are the most effective. The restored P-38s that fly today at Air shows across America don't have McKenna's original piano wire tensioner. Modern cable systems have evolved well beyond what was available in 1943. But the principle he discovered remains relevant. Immediate control response matters. The connection between pilot input and aircraft reaction can mean the difference between life and death. When spectators watch a restored P-38 perform aerobatics at an air show, they see an impressive display of power and maneuverability. They might not know that the aircraft's agility, its ability to roll and turn crisply, derives in part from a modification developed by a sergeant mechanic who bent a 6-inch piece of piano wire in the jungles of New Guinea 82 years ago. The story of James McKenna and his simple but revolutionary modification reminds us that innovation often comes from unexpected sources, not from research laboratories or engineering departments, but from practitioners who deal with real-world problems and develop practical solutions. The best ideas emerge from people who understand systems intimately, who see what others miss, and who have the courage to challenge accepted wisdom. In the final analysis, McKenna's legacy isn't just about improving an aircraft. It's about recognizing that sometimes the right answer exists outside official channels. It's about valuing practical knowledge alongside theoretical understanding. It's about having the courage to act when you know you're right, even when the system tells you you're wrong. Today, a reproduction of McKenna's original piano wire tensioner sits in a display case at the National Museum of the Pacific War in Texas. The exhibit label explains its significance, describes the modification, and tells McKenna's story. Visitors often pause at this display, surprised that such a simple device could have such a profound impact. That simple piece of bent wire represents something larger than itself. It represents the ingenuity of people under pressure. It represents the willingness to challenge authority when lives are at stake. It represents the understanding that sometimes the most elegant solutions are the simplest ones. August 17, 1943, dawned like any other day in New Guinea. The sun rose over Dobodura Airfield. Mechanics prepared aircraft for the day's missions. Pilots received their briefings. Everything seemed routine. But on that morning, a sergeant named James McKenna made a decision that would save lives, change aerial combat tactics, and ultimately contribute to victory in the Pacific. He bent a 6-inch piece of piano wire into a Z shape and installed it in an aircraft's control system. 8 minutes of unauthorized work. That's all it took to change history.